Perfect. So welcome to How to Read an AI Image. I am so happy that everyone can be here with us today. I have the pleasure of introducing Eryk to you. I met Eryk earlier no, it's not this year, it was last year, in Malaga in Spain at the Digital Art History Summer School. And I got to talk to him and I was very excited about what he was researching and what he was working on. So today we have Eryk Salvaggio, who is a researcher and media artist interested in the social and cultural impacts of artificial intelligence. His work explores the relationships between archives, AI datasets, and cultural memory with the aim of examining the gaps between datasets and the world they claim to represent. Eryk, it's all yours if you want to share your screen.
All right.
All yours.
Thanks. So, hi everybody. I'm about to share screen, but I figured I'd show some face beforehand. Thanks for being here. And now enjoy as I fumble with Zoom famously to share my screen. Here we are. Okay. If someone could give me a thumbs up that everything is clear and you can see a very, it shouldn't be clear, it should be a very noisy image, and it should be full screen. Can you see that?
You don't see anything.
No?
It says that you have started screenshot. Oh, there we go.
Okay. So you can see it now. I see a lot of thumbs up. All right. So, hi. My name is Eryk Salvaggio, and as introduced, I'm a researcher. I am involved in thinking about artificial intelligence. I have been for really now coming up on about 7 years or so. And this predates a lot of the generative AI boom that we've been seeing, where people are making images or music or videos using what we call diffusion models. Um, that's probably about as technical as we're going to get in this talk. But I wanted to talk through some of what I've learned through my relationship with these tools, both as an artist and as somebody who's engaged in policy thinking, responsibility. So I teach responsible AI at Eryk Barcelona. I'm also involved in the um, um, at RIT, involved in digital humanities and social sciences related work around AI. Um, and so that's where I'm coming from. And with that said, let's get into some of the talk. This is a talk called How to Read an AI Image. And the basic principle of this talk, the basic sort of central idea of this talk, is that AI images are data visualizations. And this is what I hope to get at and explore. First, I'll talk about why I argue that they are data visualizations, and then we'll talk about some of the implications of that. So the first thing I want to do is start with a basic overview of what a diffusion model is. What does it mean to use AI to generate an image? From a very high level, without any sort of technical background, the first thing I want to start with is a bit of a metaphor. And this metaphor is to imagine that all of us, instead of being wherever we are on a Zoom call right now, are outside in some beautiful space and it's a clear night and it's we're camping and we look up and we can see the nighttime sky and we can see vast constellations up in the sky. And maybe I'm sort of talking to all of you and I point up and for some reason you trust me and I tell you, look, there's the Big Dipper. The Big Dipper's up there. Now you might also look up at the nighttime sky at that point and say, oh, he sees the Big Dipper. Where is it? And you might look around and you have a sense of what the Big Dipper looks like. You have a sense of what its shape is because you're familiar with the constellation. So you might look up at this assortment of stars and try to find something that looks like that constellation. And so you might say, oh, there it is. I think that's it. That must be the Big Dipper. The thing about this is that it isn't. It's not the Big Dipper. This is a series of random stars. And because I've sort of encouraged you to see the Big Dipper in those stars, you're able to connect the dots in a pretty literal way to make the Big Dipper appear on screen or up in the sky in the screen of your mind. So, why am I talking about the Big Dipper? Why am I talking about the nighttime sky? Basically, I want to keep this in mind that you had a bunch of points of light up in the sky, and I told you that there was a specific arrangement that could be found in those points of light, these stars. And because I told you there was a specific arrangement, you could look at what was essentially a random stars scattered across the nighttime sky, and you could find the pattern that I told you to find. And the reason I'm telling you this is because this is, at a very high level, the kind of core principle of how diffusion models work, how image making with AI works. So let's talk about it in a little bit more technical detail now that we have some orientation. How exactly does the machine do that? Well, first of all, it has to be trained. And so what I want you to do as you're looking at this image is pretend it's a real image. And pretend that it's an image maybe that someone you know has shared. Or maybe I've shared. And I posted it to Facebook or I've posted it online and I've said, here are flowers. Flowers for my sweetheart. Because I'm very corny and because it's Love Data Week and Valentine's Day, this is all very appropriate, right? So flowers for my sweetheart, and I share an image of flowers that I've taken. These are not real flowers, right? But for the sake of our imagination, let's pretend that they are. I share this online, and really what happens is anyone with an interest in training an AI model um, can basically then take this image and they can turn it into training data. And what does that mean? What is the process of turning this image into training data? We'll go through that in a second. But there's two key things to remember. The first is I've uploaded this with words. Flowers for my sweetheart. So there is a word association with this image, flowers and sweetheart, right? The other stuff is kind of gibberish as far as the computer is concerned. But there's also an image, which is basically a sequence of pixels of varying colors, right? We have to think about this not as an image of flowers, but as from the top left across that top row, all the way to the bottom right, about 16 million pixels and about 16 million pixel values indicating what color this image is and which color appears next to which other image or which other color. So what happens when we train it? Well, we strip information out of the image. The model is designed to actually tear information out of the image about those color values. And another way to think about this is adding noise. Adding noise to an image or removing information from an image is essentially the same thing. So the first thing that happens is we get this image and it becomes noisy, right? One of the first things we notice is that the background is becoming extremely noisy because it's so represented that that data can be lost, right? Think about what remains as we go through this process. We're going to go step by step, removing information and adding more noise. And I want you to look at what stays in this image as we strip that information out. So first to go is that background. That background becomes sort of obliterated. And then as we go, we lose more and more of this image. It becomes harder to recognize, right? At this point, that background is completely gone. You can barely see that there's a green background. But you can see the things that contrast with that background. You can see the stems of the flowers. You can see the petals of the flowers. And so what we're seeing is a pattern called a Gaussian distribution. What this means is that the noise is moving through the image in a pattern where the densest concentrations of color are left the longest, as long as they're in contrast with something else, which is why that background goes away. So that contrast is what's lingering. And as we strip this information out of that image, we see, okay, we could barely tell that this is flowers. We could sort of see the petals remaining. We could sort of see the lollipop sticks of the stem. And eventually it becomes absolutely nothing. It becomes absolutely garbled. Now, what this model is learning, quote unquote learning, is the patterns of how that noise is moved through the image. And every time it introduces noise, it studies the way that noise is spread through the image, and it traces that step back. So it could go all the way back to that original image in order to create or recreate this image of flowers that it has essentially destroyed. So from noise, you can move backwards to the original image. And what it has learned is what gets stripped away and what remains in that image as a series of numbers, as a sequence of numbers that forms a pattern that shapes this image, that numbers of the pixels and the colors pixel by pixel, right? So if you were to take this exact image of noise, you could almost read it as like a code or a set of commands for recreating that exact image of flowers that we started with. But what we do with image generation is we don't use a real image of noise that has resulted from scraping information out of an image. Instead, we generate random noise and we tell it, just like I told you to look up at the nighttime sky, that there is something in this noise. That if it connects the dots, it will find a picture of flowers. And we do this by writing a prompt. So I write flowers, and the machine now looks at this and says, and I hate to do this, but the machine is then looking at the information, looking at the pixels, and it needs to optimize this noise to find the image of flowers that I am telling it is there. Essentially, it needs to clean a random image of noise up into a picture that doesn't exist. And so what it does is it scrapes noise away and it sort of analyzes this image using a computer vision software, which then says there's 0% chance that there are flowers in this, right? The computer vision program doesn't recognize any shapes of flowers. So then the model tries again. It scrapes more of that information based on sort of the patterns it learned by training. And as it goes back and forth, eventually something starts to emerge. Now, at this point, it might only be still a 20% chance that there are flowers in this image, but it has a basic outline. Now, you can see there's a couple of circles, right, and a couple of sticks. So it's following this pattern that has been learned from training that this is what a flower looks like. It's optimizing that constellations of pixels so that a flower emerges from the noise. And then it's asking a computer vision program, what's the likelihood that this is a picture of a flower? That computer vision is passing on 20%, maybe clean this up and you'll find that picture. And it'll keep cleaning that image up. Eventually, this, for example, might be a 60% chance or a 70% chance. This might be a 90% chance. And then it continues to clean. It cleans up that data, cleans up that noise rather, into shapes and recognizable images based on what it is trained upon. And then you get a brand new image of something like a flower. The computer vision program only really cares, does it have this shape, this circular shape that has come to be associated with this word flower? Does it have this sort of lollipop stick structure? That's all it cares about. Doesn't care about the background, right? That's not part of the prompt. So it just fills in that background with kind of anything that makes sense, anything that is plausible based on the other pieces of information in the data. So this is why I get to this idea that what we're looking at here is a data visualization. This is a representation of data about flowers in a training model. And it uses noise and constrains the sort of shape of noise into a kind of composite image, a kind of representation of averages about flowers. And this is at the core of how a diffusion model works. And when you're talking about something like a flower or an apple, you can get a pretty good representation of a flower or an apple. But thinking about it this way opens up a lot of really important critical questions too. To go into this, we have to think a little bit too about the image and the text that appears around an image. I talked about sharing an image of flowers with the label "flowers for my sweetheart," right? But these diffusion models are taking data from all over the web. They're taking, as has been much discussed, work from artists who put portfolios online and label their work. That's part of the data set. There are images from Wikipedia and Wikimedia Commons in the data set. And oftentimes associated with that are certain types of text. So here we have a literal example from Wikipedia, an article on peaches, and we see that there is a label, the fruit of a peach with a seed or stone inside. And so this image of a peach becomes associated in the training data with various aspects of that statement. It becomes associated with fruit, becomes associated with peach, with seed, with stone. That said, we might look at this and say, well, I understand the fruit, I understand the peach, I understand the seed, but why would this be a stone? At least in the United States, we don't often refer to the pits of these fruits as a stone. Um, but in the training data, this idea that this is a stone actually gets washed out by all the other millions of images of stones, of pebbles, of rocks, right? So it would be very unlikely that a peach would appear if you prompted it for the word stone, because that data is overwhelmed by other forms of images. Just again, to visualize very clearly what we mean is we're really talking about numbers. We are not talking about an understanding of any kind of concept of what a fruit is or a flower is. We are looking at taking an image, breaking that image down into color values, and then what the computer sees is that image on the far right, just a grid with numbers, numerical data representing which color is supposed to light up in an image at any given time. And it learns the patterns that appear in this grid and associates words with those patterns. And when we talk about computer vision, it's an older technology, but it can recognize certain clusters of pixels as things. It can recognize a dog, it can recognize a hat with a wide brim. But if you were to put these things together, it's less likely to recognize that this is a dog with a hat with a wide brim. But this technology has been getting better and better thanks to millions of pieces of training data and millions of pieces of text, including synthetic data, which is being generated by looking at images and then being told to describe them in very specific ways, taking that data and then retraining models so that the vocabulary associated with images becomes much more precise, which is the case with what OpenAI has done with DALL-E 3. And there is a risk of recreating training data. Very small risk, but if you have one image associated with only one term or one phrase, oftentimes if you find that phrase, you can generate a pure image of that image, right? You could actually replicate that. So there's a lot of argument that says, well, these models don't actually like memorize anything. They're not actually copying anything, but actually the very existence of this, even though it is very unlikely, argues otherwise, that the patterns of this image and the patterns used to reproduce an image are understood in the sense of being in the training data and being able to be reproduced. So I often talk about data visualizations, and the reason I talk about data visualizations is because that is basically what they are. When we're generating an image, I often think about it as a survey. And I think about Jon Snow and this original data visualization that came from the cholera epidemic in London, where basically Jon Snow had access to a bunch of information, a bunch of spreadsheets, which you see on the left and in the middle. But most people couldn't make sense of that. They couldn't figure out how that corresponded to anything that was happening in the real world and why people were getting sick. And so famously, Jon Snow mapped it out. He transferred people getting sick or dying to actual physical addresses, and he put it on a map of London. And as soon as he put it on a map of London, he was able to see all these black rectangles you see here are illnesses or deaths. He was able to see that it's centered on something. There was a center in this, and that center was the Broad Street pump. Um, and from that, he basically, at least anecdotally, went and smashed the Broad Street pump, water pump. People could stop getting water from that pump, and as a result, they stopped getting sick. And through visualization, he was able to see the center of the source of where this illness was coming from. And when we talk about AI images, what we're talking about really is a kind of center of the imagery in that training data that is then being reproduced. And that center is a kind of composite image of the clusters of all the images that are titled with that word or associated with a specific word. Basically, on the left, you see that first phase of noise. And if you use this exact image of noise, but you ask it to find an image of a cat, you get the image in the middle. If you ask it to find an image of a dog, you get the image on the right. Now you can see certain patterns in there actually that are shaped by that noise. You can see the fur. It's a little hard that I can't point it out, but if you see the fur, there's kind of these three almost like fingerprints reaching in the fur. You can see there's kind of a position of darkness that matches that noise. So what it's doing really is taking an image of noise and constraining that noise to the prompts we give it. It's filtering that noise through the words as if it was a filter, and it's checking that word against the training data to see, Is this a cat? Is this a dog? Is this a cat? Is this a dog? At every step. And it's filling in more detail every time it gets confirmation that it is closer to an image of a cat or a dog. These centers are a very real thing. We can look at them. If you look at the language models that are used to sort of recognize these images, we can look at the center. Um, these are centers of the neural networks that are associated with keywords and what those networks are looking for slash reproducing. From there, it basically cleans up. But there are these associations that come about, a kind of central composite of that training data that is being checked against. And so you can build images of emotional people, but you can also build images of emotional buildings and see what that word is as it becomes filtered through different prompts. It also is associated with regional stereotypes. We're talking about flowers and we're talking about peaches, and we're talking about composites that emerge from those things. But one really critical question that I think is important to ask is what happens if we start addressing that about people? If we ask for composite images of people? And here we get images that are associated with training data for regions of the world. And essentially, what we are seeing are core stereotypes. Um, we can see in the USA there is a lot of association with flags. We could see in Australia that what we are actually looking at is not a person, but almost a kangaroo or a koala. And we could get into much more troubling issues about what people look like and how they are sort of stereotyped based on these other images as well, right? Um, but this is what is at the heart of that training data in image generation. And I like to use an example because I'm an American. I look at the training data associated with the word American. And what I see is a lot of flags. I see, so on the left here, you see the training data, and on the right, you see an image created with Stable Diffusion that represents an image of an American. And what we see on the left, cowboy hats, American flags, um, but we also see this meme that is repeated with this word American in it, which is a overweight man holding a gigantic cup from a Big Gulp from 7-Eleven. And one of the things that I have noticed with Stable Diffusion 1.5 in particular is that if you ask it enough for images of Americans, they often appear with a large cup. And this is, in my hypothesis, a connection to this idea that there is a large cup in that training data because of this meme. Because every time this meme is encountered, it is reproduced as a weight. It weighs more heavily on the shape of what is an acceptable image when you prompt for the word American, which means that if someone is holding a cup, that image recognition system is very likely to say, like, yeah, that cup belongs there, right? So we're more likely to see that. We're more likely to see cowboy hats and face paint. And we're also more likely to see someone who is overweight because these are the stereotypes that exist in the training data because of memes that have been distributed, right? And so I'm using this as an example as an American. It's not a very sympathetic example in the world right now, and I understand that. But that's part of why I'm looking at it and trying to talk about it, is to think about how these images and the things that we talk about online and the way we talk about them shape what comes out of an AI system. And thinking about it as a data visualization, being able to look at this image of this American and say, this is a data visualization that is representing the data in the training set associated with the word that I just used, American, to generate this image. We could do it with the UK, and we start to see patterns. Asking for a typical British person gets you 4 pictures of elderly white men. If I ask for a typical British person again, I get 4 elderly white people and 1 woman, though you will notice that the woman is distorted, which I think is telling of something, right? If there's lots and lots of data about women in that training data set associated with that word, you would expect less distortions, but there isn't. And so we can do it again. And we can see again the same exact thing. British person in the training data is associated with elderly white men. And in case you doubt me, here it is again. One more, right? So we can make certain inferences about what's in that data set. And we can infer that these data sets are culturally biased. And that shouldn't come as a surprise because we know where this data set came from. It came from Leon 5B, which is a data set of 5 billion images that were scraped online without any curational process, without any analysis of what was going into that training data, and without any request for permission from anyone, including the artists who make up the data set and including social media. The sharing of images of flowers for my sweetheart. I was not asked about the ability to use that data. Now, you can argue that it is fair use. There are legal debates about this that are underway, and I'm not a legal expert, though I do note that just yesterday, a case arguing for fair use was lost. And it's important to note that these tools are being used for a very specific purpose, which is to generate images. There isn't really a research purpose involved. There's plenty of reasons to apply artificial intelligence or machine learning to understand things that are happening online, to analyze hate speech, for example, or to look at images and study images and how they circulate. But using this information to reproduce images or generate new images that sort of compete with other images complicates the media aspect of this, complicates the circulation of stereotypes, and circulates in a lot of ways, undermines the value of labor involved in making images in the first place. And it gets a little more troublesome the deeper you go into the training data. So, for example, we know that the training data can have access to a lot of public domain material. But we can think about public domain material not as necessarily stuff that people have shared for free voluntarily for AI companies to use to train, but also as basically any image that is older than 75 years old. And when we rely on public domain data, which I believe is a more appropriate source for training data, right? We also have to think about the biases that existed 75 years ago. And those biases included photographs. And who was photographed? Who could afford to be photographed? And who would not be photographed? So on the left of this image, you see images associated with the word girl. And this is a data set or a aspect of one big data set that really emphasizes young white children, right? Because that is who back then was able to get images made of their daughters. And those images, those portraits have entered the public domain. So when you train an AI model on all of the girls in the data set, you are very likely to get a white girl. Now, by contrast, if you look at the training data for the phrase black girl, what you see is what you get on the right, at least my right. And what you see are highly sexualized images of black women. And you also see some black squares. And the reason you see black squares are because I have blocked out hardcore pornography, which is literally in the data set, literally in the training data with the association for black girls. And this echoes a real finding from Dr. Sophia Noble back in 2016 that Google results for black girls led to, by and large, pornographic content. And this needed to be addressed. And Google had to basically rig that search result so that it could lead to information about young black girls and health, for example, as opposed to pornography. So these issues about the internet as a raw and unfiltered, uncurated source of data lead to highly problematic results because the internet is heavily biased. The internet includes racism. The internet includes racial stereotypes. And this is, I think, a very important and critical point of view to bring to the generation of these AI images. Because we can then ask really complex questions about why Midjourney thinks that criminals look like this on the left, but that professors look like this on the right. And so increasingly, I've been very flummoxed by the idea that we don't need to think about diversity in AI, or we don't need to address biases in AI when we know that a machinic bias exists and that a systemic bias is being baked into the images that we are generating with these tools. And we need to think critically in order to mitigate those biases and soften those biases and avoid reproducing those biases. If not, reconsider the project of using data sets like this in general for the sake of creating media. Another great example came from Rest of World, a journalistic organization that studies technology from multiple perspectives, global perspectives. And in their experiment, they generated 3,000 images of the word Mexican. And what they found, or for a Mexican person, is that every single one of them had a sombrero on. And so I say this just to emphasize that these are reproducing stereotypes, and they are reproducing very lazy stereotypes. Um, Part of my research with the Flickr Foundation last year involved looking at training data and looking at how these tools are tested and calibrated. And we learned that they are largely tested and calibrated on a Flickr dataset. That Flickr dataset was not created to generate images. It was trained to analyze Flickr. It was designed, or not trained, sorry, it was shared to analyze Flickr. It was shared with experts long before generative AI was a glimmer in anyone's eye. And the goal of that data set was actually to identify and resolve biases. And rather than using it for that purpose, this data set became a way of testing image generation models, training a model and then testing it to see can it reproduce the biases in Flickr. So literally a data set that was designed to help identify gaps and in content was then used to benchmark image generation systems, which means that they were benchmarked against gaps so that if those gaps existed, they would reproduce those gaps. Now, it's more complex than that. This is a 5 minute, 2.5 minute section of a 50-minute lecture. But here's where that data came from. Primarily North America, primarily Europe, primarily places where people used Flickr. And as a result, some of these systems have inherited biases of geographical location. So if you generate an image of a city in Midjourney, you mostly get very Western cities. They look like a hybridization, a generalization of Western cities. This is 4 images of cities, just the word city, not asking for specific cities or Western cities. And you'll note that they kind of look like a hybrid of New York, San Francisco, and London, maybe a bit of Hong Kong, right? Um, but what happens if you ask for an image of an African city? By and large, what you get are the results of journalism, combat zone journalism, philanthropic journalism, asking for help for refugees, right? Because photographs of people living real lives in real cities in Africa, for example, are not well represented in the data set. And instead, what is represented are these biased images of war zones, combat zones, strife. And so this biases the tool in a very dangerous way. The Senegalese curator, Linda Donia, has written about this and writes that a prompt about a building in Dakar will likely return a deserted field with a dilapidated building, while Dakar is a vibrant city with a rich architectural history. For a technology that was developed in our times, it feels like AI has missed an opportunity to learn from the fraught legacies that older industries are struggling to untangle themselves from. So we can see them side by side, and we can think about what are we visualizing as a data visualization? What is the data that is structuring these images? And I think this opens up a lot of tools, a lot of ways of thinking critically about AI, a lot of ways of thinking critically about the images that we circulate when we use AI, and a lot of, I think, important questions to ask about our relationship to these images and what they reinforce about our own biases and how they reinforce those biases when they are circulated. Um, I attribute this to something of a haunting. And this is a very imprecise term, but I think it helps root us in a kind of humanist orientation to these images. And by haunting, I reference here Avery Gordon, who talks about haunting this way. Mediation describes the process that links an institution to an individual, a social structure and a subject, and history and a biography. In haunting, organized forces and systemic structures that appear removed from us make their impact felt in everyday life in ways that confound our analytic separations and confounds the social separations themselves. It is the intermingling of fact, fiction, and desire as it shapes the personal and social memory. What does the ghost say as it speaks, barely, in the interstices of the visible and invisible? And I have applied this work to one last question about archives before we get to questions. In my work at the Flickr Foundation, I wanted to investigate legacies of archives in the training data. And I became really interested in something called stereo view images. This is an example of a stereo view image. It is essentially designed to be held up in a device, inserted into a device. This is a technology that emerged around the 1890s and allows you to look through the device and the two images sort of overlap. It's a trick to deceive you into giving these images the illusion of depth, kind of like an early version of VR using photographs at slightly off angles. So you can see the moon is slightly ajar in both photos, but when they overlap in your vision, gives you this illusion that the moon is floating. And this was a really popular technology. In fact, it was the most popular way to distribute images in the United States around this time, the 1890s to about 1910. And so you can see here, when you put those images together, you can kind of create an illusion of depth. I was interested in how AI systems generate stereo view images. And what I found consistently is it kind of represented or presented what I can only identify as a kind of colonized gaze, a way of looking at the world where there are subjects, oftentimes with faces obscured, that represent a very particular place in the world, and also a kind of relationship to those subjects. We see, for example, people in a kind of Victorian dress walking on beaches, and these images are only for the word stereo view. I'm not asking for palm trees. I'm not asking for Victorian era or anything like that, right? Just the word stereo view gives you these images. And that isn't too surprising because that is the period where these photographs came from. Um, but they also don't work, in case you're wondering. Right? They are not true stereo view images. But more importantly, is that sometimes they aren't even stereo view images. And something that is encoded in this word stereo view is this gaze. Here we see a group of children standing in front of a building, being looked at for who knows what reasons. But we aren't even getting that side-by-side view, which is literally the definition of a stereo view image. And when I look around for stereo view images, one of the things I notice is a significant area, a significant archive or source of stereo view images is the Library of Congress here in the US, which has an entire collection dedicated to stereo view images documenting the American occupation of the Philippines. And so when I look at an image like this, and I see an image like this in the training data, my mind says this is a remnant. This is reproducing that colonizing vision. And that vision was used to tell a very particular story about that occupation of the Philippines, that the United States was liberating the Philippines, bringing a kind of education to these people, and framing a really sort of superior relationship on behalf of the US to the people who were living in the Philippines. And this is being reproduced by AI, not for asking for it, but simply for asking for a particular type of image. And I think about this as a haunting, as a way of which the objects, and by that I mean specifically photographs or the things that we collect in an archive, emerge through the training data into the images that we produce online. And that's my talk. The rest of this time, I think, is for questions. This is a link to find my website and to find my newsletter. The QR code links to my newsletter. And I'm on Blue Sky if you're looking for me. But I'm also happy to spend the next 15 minutes or so, I guess, with any questions people might have.
Thank you so much, Eric. So yes, if there are any questions, put them in the chat. Oh, Christina, I see. Feel free to unmute. And if you can, oh yeah, you can.
Great. Thank you so much. That was such a rich and really deeply stimulating talk. I'm coming at this as both as somebody who teaches at the University of British Columbia, and then somebody who's also involved in kind of the admin research side of things as the SHRC rep. And so I'm interested from two angles, and I'll ask both my questions. You can answer both or none, or any of the above. And so my first is really concerning AI and teaching, because as I try to think through the implications. I so often see students, particularly with images, see it as less necessary to kind of attribute properly and so on. And so I feel more and more worried about the kind of AI bandwagon that I see happening at my own institution and probably across Canada, in terms of all of us being really ill-informed about the ethical issues, particularly around labor and the environment, and as you've really shown us, the kind of biases we see, and also the kind of citational justice there, I guess. So I'm
Mm.
wondering if you could talk a little bit about teaching, and then I'll ask my other question, which is basically this concern I have around the kind of add diversity and mix model, which is, if we just make this more diverse, our problems will be alleviated. And I wonder about this because, I mean, even at the university level, we've seen that approach of our institutions will be changed by adding Black people, or there's a real kind of often, I think, an impulse to think that the institution itself doesn't need changing, right? And so why, I'm curious as to how you think we end up at a place of greater justice, if that's where we're going, hopefully, um, if the underlying issues of labor and ethics, as we all know, are really faulty in how those tools have been created. Does that kind of make sense in terms
Yep.
of my worry? Okay, thanks very much. That was such a great talk.
Sure. Yes. So I can address the diversity question, first of all, by saying that there are people who are better positioned to answer that than me. I highly recommend, if you're looking at questions about AI and diversity, and particularly what you're talking about is sort of system level thinking around this, looking at DAIR, DAIR, and that organization and the type of work that they're putting out. Scholars like Timnit Gebru, Abiba Parhane, Sophia Noble, those are the people that I would look to and listen to. But in terms of oh, sorry, my timer. So in terms of where I come from that perspective, is that from a technical perspective, in the sense of how I understand these models make sense of images, there's a real question in my mind about diversity fixing anything in the sense of training data, as in add more people, add more diversity of images. And we don't know because there isn't a model that has done that. There is not a model that anyone has done that work of figuring out how to calibrate percentages. But I do know that a diffusion model operates by stripping images down to its base level and aggregating the base level of all of those images, and then generating from slicing off something from that aggregate central tendency. And to my mind, there is no way, regardless of how distributed or diverse the training data is, that you do not end up with stereotypes, that you do not end up back at square one, where you have just now taken a very diverse data set and turned it into a stereotype. We have seen efforts to do this where there was a data set argued by, or at least it was argued, that Stable Diffusion had trained a model primarily on data from India. And a scholar and a friend of mine, Dr. Avijit Ghosh, looked at that and generated these images and found out, oh, it's generating stereotypes of regional stereotypes from India, which is probably in hindsight exactly what we might have expected. So I think this question of diversity in the training data is it's unanswered from like a purely like research perspective because there isn't a model that's done that yet. But it hypothetically, the best that I can say is I very much doubt that diversity in the training data is actually going to clean up anything in terms of how these things are biased and skewed. Um, Open to conversation about that. Like I said, I don't know, but my hypothesis is that. As far as teaching goes, I'm trying to work through right now a lot about the education space, how we teach these tools, but mostly how we teach our relationship to the tools, because there is so much framing around, particularly large language models, that it is answering a question, for example, when actually it is not answering a question. It's predicting text that comes after your question, right? And when you understand that, that's a fundamental shift, I think, in what we think these tools can do and what we trust these tools to do. And with image generation, it comes down to that as well. There's a fluency as opposed to a literacy. Literacy is so often defined as how do you get a prompt to generate the type of image you want, or how do you ask an LLM the type of question that gets you the right answer. And I think that type of frame on literacy is really barking up the wrong tree. I think we need to critically assess the story of these systems in our students' minds, from training data to processing to the interface, which is an interface that is trying to tell you a story, that it has authority, that tries to tell you a story that you are the question asker and it is the question answerer, that we really need to challenge at every step of using these things. And I also think that this is a really good opportunity to ask very good critical questions from the humanities, from data science, from all kinds of walks of life about that relationship, about what this text is doing, about what's happening in our heads when we engage with this technology, and how to step back from our role as the user to see ourselves as the steerer of the system. And that is very different than saying, well, here are the keywords you can use to generate a good prompt, right? Or generate a good answer to your quiz question. It's about thinking what is going on in your head when you see this thing generate the text, and how is that persuading you to believe certain things about this system. And that isn't as difficult as I think it's positioned to be. It's just that not a lot of people are taking it from that angle because we're focused on a utilitarian priority. We're focused on getting students to say, I need to use this thing to generate code, but they don't, right? Actually, for a student, generating the code really needs to come first, because even at the most generous use of this tool, you need to be able to verify the code that comes out of it. So I really want to get to this critical reassessment of our relationship to the technology, that it's not about what's happening on the screen, it's about what's happening in our heads in response to what's on screen. And from there, I'm trying to build out a kind of pedagogical practice that really fundamentally questions AI at every step of its use in order to challenge and really decide where and when it is appropriate or inappropriate to use. Anyway, I could talk about this for too long, and there might be other questions.
We have a few other questions.
Okay.
Yes. So the first one is if you wouldn't mind sharing your slides with us. I know there were a few links that I also wanted to like check, and it's a few references that I like to go and look. So if you don't mind, maybe you can send them to me and then I'll distribute them to everyone who sign up. We also have a question that says, is it possible for anyone to see training data for a generated image?
Yes. So real quick, Leon 5B, the data set that I talked about, was shared and distributed as a online open source training set. I have nuanced feelings about this because it does mean we can go in and assess that data. We can analyze that data. We can find out problems with that data. And ironically, that is exactly what happened. They found child abuse material in the training data, and as a result, they took it down. They then cleaned that up. They got dragged kicking and screaming to clean that up, but they did it eventually. And then they reshared that training data as Relayon. And right now you can you can find that as a data set. You can also go to a website called Have I Been Trained, which is designed to be a tool for artists to see if their work is in the training data. But you can also go there and type in keywords, and you will see a sample of Relayon's terms associated with that training data. So that exists there. Other models, so Leon was used for stable diffusion, And most sort of low, I want to say like apps and stuff, because it is publicly available for free. Companies that don't have a lot of money are using it to train AI. OpenAI is not. We don't know what's in OpenAI's training data. Despite calling themselves OpenAI, they're closed, and we don't know what's in that training data. And that is to protect them legally, because they can't be sued for copyright violations if no one can prove they don't have copyright violations, right? So this is a strategy that is becoming more and more common, and open data sources are less likely, but you can find it. Um, yes, I think that was your question.
Yes. And then we have
Okay.
another question that says, do AI images make their way into the training data for more AI images? Would this perpetuate stereotypes?
Yeah, we've also seen something called model collapse, which, not to get into it too much, but with images, you basically have like a low generation or low quality image that it is trying to learn from, but a lot of the details in that image have already been sort of like blurred away. Like the human eye can't see that lack of detail, but when training, you're not actually getting very much out of it. So there is an effort underway to flag AI images so that they are not being retrained. That said, um, who knows? A lot of these places are not actually thinking very hard about what's getting put into their training data. But I do look with suspicion at things like Meta asking you to flag your AI images if you share them, right? Because that is a way of filtering that out of the training data. Um, so these biases in a theoretical world where a bunch of AI images were generated and a new AI system was trained on that data as the output of that model to train new models, you would end up just reaffirming the distribution, right? So you would recirculate, you would regenerate the same stereotypes that exist in the basic model. The counter argument to that is synthetic data. Can you generate images of people and try to make them more diverse? Which I think some people are probably trying. But as I said in the answer to the last question, I have my doubts that it's going to succeed, because you're still averaging that distribution. So it comes down to the average, the diversity in the keyword. It comes down to that relationship between typing a word and getting an image. It's what's associated with that word will almost fundamentally always be a stereotypical image or a biased representation, because that's what you're literally asking it to do, is give you a stereotype or give you a biased representation of a flower or an American.
I'll ask one last question, which is one of
Mhm.
mine that I always like to ask people who do this work. Why are models so bad at hands and faces and feet?
Um, Faces they've gotten pretty good at, I have to say, but hands mostly because there are not enough consistent patterns in a hand, and the hand looks very similar, right? Images of hands are very rarely a picture like this with the word hand associated with it, right? If hands are mentioned in training data, it's like they're doing this or they're doing this or they're like, right? So they're in all these kinds of shapes. And so the model is seeing like basically this, right? Like six fingers, like closed fingers, right? And so this sort of overlap of how to make sense of a hand is so widely distributed that it can't figure out exactly that, like, there's five of these and then stop. For the same reasons that AI, including LLMs, struggle to count. It's because they're predicting patterns. They're not looking at a hand and saying, here's where the hand begins and ends. They're looking at pixels that are in the shape and the patterns of which those pixels appear in order to reproduce those patterns. So your hands becomes like this, but it draws one, then two, then three, then four, then five. It doesn't know that that's where it stops. So it then goes to six and then seven and then maybe eight, right? It doesn't know that this finger is shorter than this finger. Eventually, it may. That's actually setting a priority for the training and where to emphasize your training. Get a bunch of hands, train a bunch of hands, right? So it could be done. It's a technical limitation at this point.
Thank you. Eryk, thank you so much for your time, for your expertise. Thank you to everyone who made it today. I mentioned it in the chat, but yes, if Eryk will send me the slides and I have recorded this, we'll upload it to our YouTube channel, but I'll also be sharing the link to the YouTube video. Eryk, thank you so much for talking with us for today. And thank you again for everyone who came, and I'll see you all soon in another training that we have. Thank you so much.
Thanks, everyone. Thanks for coming. And thanks for inviting me. It was great to be here.